just a moment or so, and we will get going with our webinar in just about a minute, maybe a minute and a half.
All right, it is just about 10:02. Should we get going? Okay, we'll just kind of start slow while people trickle in. Good morning, everyone. This is Katie Sealing at the Lighting Design Lab, disembodied here voice. See Shaun's head. Welcome to the first day of the Fundamentals of Networked Lighting Controls. Hopefully you're registered for tomorrow. If not, go to our website and get registered. It looks like everybody is, though. Just some housekeeping stuff. During the class, you're going to be muted, but there is a chat box over on the menu bar that you can type a message to us, and Shaun will answer, or we'll try to get that taken care of during class. Shaun's got some built-in time to take questions, but go ahead and ask anytime. And participate in the polls. He's got 4 or 5, multiple choice, single choice polls, and you can sort of gauge your learning, and we can gauge your interest during the class. And then after the class, there's a short survey, super short. Please take that. And a recording of this class will be put up on our website along with the handouts. There's also over on the menu bar, you can download the handouts right now. I suggest doing that to have with you. Any questions after the class, reach out to us at lightingdesignlab@seattle.gov. And it's a seattle.gov address because we are powered by Seattle City Light. Without Seattle City Light, the Lighting Design Lab would not exist. And we are a partner with Mia's Better Bricks initiative. You can't click the logo right now, but when you get the presentation, you can, or just Google them. They help us with these courses. And just in case you're not familiar with the Lighting Design Lab, we have kind of 3 main circles of stakeholders, and they all overlap into the Lighting Design Lab. We connect end-use customers with trade allies with design allies, and do education for all. Besides education, we do technology evaluation. We offer tools and resources on our website. Unfortunately, our cool building, which you see behind there, was closed like most everything last year, but we'll get up and running, eventually again. And then information aggregation. We'll bring you synopsises of conferences and papers that come out, and have sort of layman's terms available to you.
Thank you, Katie.
Thank you, Shaun.
So welcome, everybody. Welcome to another fine, and I do mean fine iteration of our network lighting controls class. In a future time, we'll be able to revert back to doing these as our full day hands-on class. But for the moment, this is essentially a distillation of the hands-on network lighting control class that hopefully will get you most of the way there with respect to the kind of systems that we're talking about and some of the programming issues. To introduce myself, for those who don't know, my name is Shaun Darragh. I am a lighting designer. Been a lighting designer for, gosh, more than 30 years now. I've been fortunate in my career to have worked in almost every facet you could name of the lighting industry, with the potential exception of distribution sales. But most of that career has been actually as an architectural lighting designer, leading several design practices. And I've also been incredibly lucky enough to have spent a lot of time as a lighting educator, both here at the Lighting Design Lab, in guest appearances at various places, and off and on at the University of Washington in the architecture department. So that is a little bit about me. What I'd like to know now is a little bit about you. If you would be kind enough, let's see. I am about to launch my poll here. So if you could tell me a little bit about yourself. If we were meeting in person, we would actually be having a conversation. Sadly, that's not really tenable in this kind of webinar setting. So please go ahead in the poll and give me a little bit of information about you. How do you typically kind of identify yourself within sort of one of these 5 extraordinarily broad categories? Are you a manufacturer? Do you work for a rep agency? Or within rep agency, let's also consider distribution and sales. Are you a specifier, so architect, engineer, lighting designer, similar? Are you a trade ally, a distributor, so contractors? Or are you a government? Do you work for utility staff or a program implementer? Your website resources is not displaying all of the 2021. Okay. So we have, and actually while you're voting, I should also point out, as Katie had mentioned, sort of a bit of housekeeping. If you go to the handouts tab while you're doing this, it would be useful for you to be able to download particularly the homework. Yes, indeed, there will be homework for this class. I know you weren't expecting it. But go ahead and download those at some point during the course of the next 2 hours. All right, so I am going to close, and then I am going to share the results. So we have predominantly, we have designers and or salespeople, reps, some utility staff, some manufacturers. This is a good distribution. So welcome everybody. I'm glad that you're all here. I hope you're all glad that you're here. And let me close this. This will help me. And without further ado, let's dive ourselves in to the day. So learning objectives. What we're really going to be covering today is some of the basics with respect to network lighting controls. What are some of the common control strategies? What kind of hardware might we be talking about? How might we configure some of these things? And we'll also be talking about how to do some specification of these systems, some procurement of these systems, and also talking a bit about some of the setup for these things. And some of these learning objectives will bridge into tomorrow. So we'll see that as we move forward. So let's start off with the very beginning here. Why do we want to use advanced lighting controls or networked lighting controls, right? The idea is that we want to be able to take most advantage of our investment in lighting systems to be able to maximize their benefits to all of us within the built environment, right? What are some of the things we might talk about? Well, flexibility, sure, satisfaction, aesthetics, maintenance. We can go through all of these things. But the idea here, sort of from the very beginning, is if you buy a piano and you don't tune the piano, you don't get the proper benefits of that piano, right? So let's start from that basis and move on and talk about some of these. So flexibility. In my world, the most important reason for using advanced lighting controls is flexibility, space flexibility. You want to be able to offer as many different ways to interact with your architectural investment as possible. And you want to make sure that it's going to function the way that you're hoping it will. This is a great example here. These are 3 different lecture halls at the University of California in Davis. Now, let me be clear, these photographs were taken several years ago when I was working on a project there called their Smart Lighting Initiative. They may have changed by now, who knows? However, at the time, none of these spaces had significant lighting controls or any dimmability at all. So I would ask you, if we were sitting together, what is the #1 way that lectures are really conducted today in most halls like this, right? Is it somebody standing at the blackboard or chalkboard? In some cases it might be. If you're in a calculus class, that may be the case. But frequently, you'll see that every single one of these spaces is equipped with large projectors. So from a flexibility standpoint, having the ability to go ahead and dim the lighting down so that we're not washing out the screens, but we are still providing enough light so that students can, write notes. Those who still write notes by hand. That becomes a big flexibility issue, right? It's very difficult in some of these spaces to actually be able to control the lighting in such a way that you can even make use of the primary task, which is really unfortunate. All right, so flexibility is one thing. What about productivity? There are a lot of elements of productivity, right? We've talked about productivity in the lighting industry for many years. Jennifer Veach, National Research Institute of Canada, I believe, if I'm not mistakenly calling out where she worked on a study in the early 2000s having to do with quality of light and productivity. And a lot of that sort of same stuff really extends into lighting controls, right? We all like to be able to do things like have control, tune our light levels so that we are getting the light that we expect that we're going to get, not too much, not too little, balancing contrast and brightness, reducing glare, and actually being able to have the ability to change our lighting and our light levels according to whatever specific tasks are. Because that really does lead right into user satisfaction, right? We all like to have personal control over our environments. The more control we have over the environment, the happier we are. And a number of studies have shown us that when particularly private office users are given the ability to dim their lights down, they will. They'll dim them down below whatever light level the design team has initially suggested. So that gives user satisfaction. It also gives a certain amount of energy savings, right? These are good things to be able to do. Maintenance. So modern light sources are LEDs, right? What is an LED? An LED is basically a solid state device. So like all solid state electronic devices, the #1 enemy is heat. If we take our LED light source and we do what we call underdriving to it, we dim it, that effectively means that it's generating less heat. That theoretically means that we are going to potentially extend the lamp life. So by going ahead and using lighting control systems, turning the lights off when we don't need them to be on, task tuning so that the lights are lower in intensity than they otherwise would be, all of these things can lead to significant improvements in lamp life and longevity of the system. And some systems have a variety of different talkback features. So they may offer some idea that the junction point of the LED is running too hot or the driver is running too hot and there may be some issue there. So that's a potential maintenance issue as well. Another one we all know about, sustainability programs, right? The relatively new kid on the block, although it's been around for a few years, is the well building standard. I hope everybody has heard about the well building standard. Think of well building as LEED for people. So LEED is predominantly about the physical built environment, right? It's about the health of the building. It's about the materials of the building. Well building standard actually extends that and says, well, what about the people that live in that building? So from a lighting perspective and a lighting controls perspective, the primary elements that we would think about with respect to with respect to well, have to do with things like circadian lighting, have to do with things like user comfort, freedom from glare, biophilic change over time, these sorts of things. But there are a number of sustainability programs we might consider: Build Green, LEED, the Living Building Challenge. Effectively, any one of these kinds of sustainability programs that you would want to work on or you would want to have for your project, they're all going to require some level of advanced lighting controls in order to meet it as essentially a fundamental, right? Okay. Energy savings. We all want to save energy, right? It is very easy. I'll show you actually in the course of this class a couple of case studies where we save extreme amounts of energy with respect to lighting controls. But I would tell you that the reason that energy savings is so far down my list here of reasons to use advanced controls is that from a realistic standpoint, it's more important to have enhanced productivity. It's more important to have flexibility. It's more important to have better maintenance. All of those things, at least from a financial standpoint, are more important than energy savings. As people who care about the planet, as sustainability gurus, as utilities, we are all interested in energy savings. But I would submit to you that if you are working with a client and you lead with energy savings as the reason you want to use a lighting control system, you're not going to be as successful as if you lead with respect to productivity, user satisfaction, flexibility, all of these things. So we call those, sort of wrap them up as what we call non-energy benefits, which really tend to outweigh the energy savings. However, the energy savings are significant and really important. So they are here, they do deserve to be here. And the Design Lights Consortium a few years ago did a really interesting study where they were looking at potential energy savings across a wide variety of typologies. And what they found was that we could characterize energy savings anywhere from something like 15% energy savings annualized all the way up into the 70s. Although that's kind of a bell curve, right? Most of the savings happen in the, let's say 45 to 55% range, which really actually ties in beautifully with most of the studies that have gone before, right? So if we even went back to the 1999, 2000 or so study that Francis Rubenstein did at a GSA office building in San Francisco, they were finding 40 to 55 roughly % energy savings with a variety of different energy saving strategies as well. In fact, a lot of this has been codified, right? You'll see this in this appendix here. This is from the Bonneville Power Administration, the BPA, one of the big hydro producers, federal hydro producers here in the Pacific Northwest. And these are some of the energy savings that they associate with a variety of different control strategies in order to estimate savings for rebates that their partner utilities might use, right? So you'll see 40, 50, 55, these kind of percentages here. This is all well understood at this point. Energy codes. We certainly need to pay attention to energy codes. In fact, the Seattle Energy Code has just been updated. We, Lighting Design Lab, just partnered with the Seattle DCI to go ahead and put together a series of energy code update webinars. If you are interested in specifically the Seattle Energy Code and changes, go to our Lighting Design Lab webpage and you'll be able to actually find the recorded webinars that we put together there, some really good information. We'll also talk more about some ideas about energy codes a little bit later. I think that will be tomorrow. And of course, there are others, right? This is my list, and the order of the list is specific to me, right? It's what I have found to be useful over the years in order to get owners to install lighting controls, in order to get end users to understand why we're installing lighting controls. And I found it very helpful. Your list may be a little bit different, and that's okay, right? Whatever works for you is what you should really kind of look at. And I will say that the order of the list might change depending on where we are, right? Here in the Pacific Northwest, we're blessed with some of the lowest energy costs, electricity costs anyway, in the country, right? If I was having this conversation in Hawaii, where electricity rates are multiples of what we pay, the energy savings might jump a little bit higher on the list, right? So you really have to kind of bump those around as necessary in order to make sense with what you're doing and your specific needs. Okay. So those are some of the reasons that we might want to use advanced lighting controls. Let's talk a little bit about the basics behind lighting controls. I tend to think of at least the very, very, very fundamentals of lighting controls being three elements, right? There's kind of a three-legged stool that everything else appends from. So the first of these is the power circuit, right? A piece of copper or aluminum, electrons can whiz back and forth, and that little dance is what delivers power to essentially everything that we use today, right? Motors and light sources and all kinds of various different things. So the power circuit is what delivers the energy, right? Now, any of you who may be of a certain age, may have grown up years ago, you might remember, let's say you had a job in a supermarket growing up, and at 5 o'clock in the afternoon, you were in the back stocking, and you might hear a chunk, right? Or like me, I worked at a donut shop. I worked at something called Mr. Donut, which is a predecessor to Dunkin' Donuts. So I would pedal my bicycle down to Mr. Donut, and I would get there at 4 o'clock in the morning, and I would wend my way into the back of the shop, and I would have to turn on the lights from a circuit breaker panel, right? Click, 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 click. Of course, they were switch-rated breakers, right? Anyway, so those are examples of what we call power circuit control, right? So essentially, you have a power handling device that then provides power to a presumably large group of light fixtures or similar, right? And you are essentially giving what we would think of as kind of wide area control. So the ka-chunk in the supermarket would, of course, have been a contactor, right? A contactor turning on maybe the parking lot lighting at dusk, or the facade lighting at dusk, or turning it off in the morning, whatever that ka-chunk happened to be. But the idea is that you're using essentially, think of this as an enormously big, broad brush for lighting controls. A more modern way of thinking about lighting controls, and this really sort of starts to come from theater initially, is the idea of the control zone, or if we're talking about theater, we would call it a channel. The control zone is a logical grouping of light fixtures that are always doing the same thing together, right? So if I have a fixture here and I have a fixture here, if they always want to dim up and down together, they can be on the same control zone. If there's ever a time that I want this fixture to do something differently from this fixture, that has to be a different control zone, right? Because physically there's a device telling this to dim, and I can't break them up if they're on the same physical device, right? So they might be the same grouping as a power circuit, but more likely they're independent from the power circuit. Most of the time, we actually feed a whole bunch of control zone devices from one circuit these days. So that simplifies installation. It also simplifies procurement and a variety of different things. An example here. This is the basketball court for the Reebok World Headquarters back in Massachusetts. Of course, everybody has a basketball court in their office, right? So this is a place where the employees can come and blow off some steam, as they are here in this photograph. But it's also a place where we can come and have Shaquille O'Neal come and give an address or be presented some kind of award, or it's also some place where, you know, the local Massachusetts basketball kids might come and have championships, whatever. So the needs range from the ability to have just sort of intramural play to, I forget what NCAA level we lit this to, but also to the ability to have relatively low light level, right? Flexibility so that we could have convocations and things in here. If you look, you'll notice that there, in the old spaghetti line annotation that we all used to use, there are 4 control zones going to each one of these fixtures. So each one of these recessed fixtures, we call them recessed multiple accents. There are 4 ceramic metal halide lamps. We have 4 different control zones so that each lamp in each one of those fixtures can be controlled independently. That gives us 4 different light levels that we can choose from. It's not perfect because they're aimed in different ways, but it's pretty close. And the fluorescents lighting up the ceiling here, lighting up the flexible ducting, they're also dimmable. So we have a huge amount of flexibility within this space. Of course, if we were going to do this today, we would just go ahead and make everything dimmable LED so that we wouldn't have to worry about quite the same issue with respect to multiple zones. But we probably would have several different control zones within this space. I hope this makes sense. One real thing about control zones, if you ever have 2 different types of light fixtures, a downlight and a track head, a downlight and a linear fluorescent or linear LED uplight, never, ever, ever, ever put them on the same control zone because you're always going to want something different to happen somewhere. All right, here's a couple of examples. It's a fairly prosaic example. This is the North Seattle College Health Building, right? This was done with Shaq Deslani Architects a number of years ago. And you'll notice that we have, you know, I'm realizing that you're probably not seeing my cursor. So let me get my spotlight. There, you probably should see this now. I hope you see it anyway.
Yeah, we can see it.
Okay. Sorry, it's been a while since I've done one of these. You'll notice that we've annotated controls here a little bit differently, right? We're using A, B, C, D annotation rather than the spaghetti lines, right? So in this one college classroom, this lab classroom, we have 1 control zone. These, of course, are fluorescent. Today we would do them with LED. 1 zone in the front, 1 zone for the ones sort of a little bit away from the front, 1 zone for the whiteboard, 1 zone for the under cabinet, 1 zone for the downlights at the perimeter lab stations by the window wall. So you'll see that we've zoned this specifically so that we can maximize flexibility in here, right? We can have additional light down here at the front for demonstrations if we need to, or we can dim it down so that we can have projections. We can have the whiteboard on or not as necessary. For the fixtures in the perimeter, we of course have daylight control, we have occupancy sensors, and we have multiple scene control in this particular place. Now with the A, B, C, D, and so forth, that's an example of how I would annotate what I call a room controller, right? So in this particular project, each individual room is its own little network, right? These are all network lighting control devices. They all speak to each other, but they don't speak to a wider network, right? They don't speak to the building as a whole. Now, if we go to a system that does have the ability to speak to the building as a whole, we might want to look at that a little bit differently, right? This is Washington State University. This is Troy Hall. This is a Perkins and Will project. And you'll note that these light fixtures in this office here are these light fixtures in this office here, right? So that orients you a little bit. We're kind of looking at it from this direction. The linear LED here is the linear LED here. So you'll see that we've gone ahead and done the similar kind of thing, right? We've identified specific control zones. zone 1-27, zone 1-27, zone 1-28, zone 1-30, zone 1-33. What does all that mean? And how does this relate to, say, the control circuit, right? The control circuit, we might have 1 or 2 or 3 individual circuits powering all of the lighting on an entire floor. So that no longer has any relationship at all to how they're actually being controlled. It just means that they're getting some power. And beyond that, it's all a logical kind of grouping. So why have I got this set up this way? Z1-27, what does that mean? I've got a building here that has 4 stories. 1 story is below grade from this side. And I want to have all of the light fixtures controllable as one group, right? I want them all to be basically one unified network system. Great. That means that I need to be fairly succinct with respect to how I annotate my zones, right? What speaks to each device? Well, in this particular case, the nomenclature that I use is Z1, zone 1. 1 stands for floor 1. So this is floor 1, floor 2, floor 3. The underneath going down to the other one, I forget whether we call that ZG or Z0. Essentially, you have zone, what floor it is on the building, and then sequential number. 1, in this case, 27, 28, 29, 30, right? That gives you the ability to provide unique identifiers for every single zone in the entire building. It does require a certain amount of discipline, but that discipline pays off handsomely when they're trying to maintain and also when they're trying to program the system. Now, you can extend this up or down, right? This is extremely flexible. So this is one building on a college campus. The largest control system I've ever personally designed was for a 20-building college campus, all networked together over in Saudi Arabia. $10+ million of lighting controls, but we wanted it all to be networked together, right? So in that particular case, the nomenclature was Z1, so Z1 dash, whatever, Z1 through 20, that stood for zone, what building it was, then a number for what floor it was, 1 through, I think there were up to 8 floors in that particular project, and then what zone on that particular floor. I hope that all makes sense. Like I say, it does take some time and some effort, but it is well worth doing. So let me give you a funky cool example. This is the relaxation room at the Canyon Ranch Spa, which oddly enough, I literally saw this room on LinkedIn like 3 weeks ago. Like, wow, I designed that. So this is a space where if you're taking treatments at Canyon Ranch Spa in Las Vegas at the Venetian Hotel, after you've had your whatever treatment you're going to do, your massage, your water treatment, your laconium, whatever, you can come here and relax and kick back. I would ask you all to give me some guesses as to how many lighting control zones we have in here, but that would be a little challenging. So let's just go through some of them, right? This again is a fairly high-end example. You're not going to do this on every project or even most projects, but let's start with the wall. We have a textured white wall and then a honed sort of polished wall here, right? They're going to be 2 different textures. They're going to take light differently. In order to be able to balance these, there should be at least 2 control zones here, right? Control zone 1, control zone 1, control zone 2. Okay, so we've got that, great. Could also be 3. It's okay to break these up into 3 if you want. It's always fine to add more control zones. It's usually a problem to have too few. So what about some others? Well, we've got these decorative pendants here, actually manufactured locally by Charles Loomis. So we've got a good Northwest connection here. So these decorative pendants should each be sort of controlled in groups so that we can have sort of some level of slowly dynamic change over time that hopefully people won't notice, right? And we've got a fake oculus here. So we've got light that we want to dim that up and down. And then there's some things that you can't see, right? Tucked up in here, we've got spotlights, theatrical spotlights that are doing things like giving us the shadow pattern on the floor, because if we were going to do the real shadow pattern from these light fixtures, these would have to be too bright to be useful, right? So that's another. And then there are some other accents tucked up in there that are highlighting the water feature here. So each one of those things wants to be on its own control zone. I hope that makes sense to you, but you really want to be able to fine tune the visual field in this space. This, of course, is not about energy savings, although to their credit, Canyon Ranch's credit, they wanted to be highly sustainable, or as highly sustainable as they possibly could be. So most of the lighting on this particular project, and they did this 10 years ago, most of the lighting here is either LED, compact fluorescent, linear fluorescent, or ceramic metal halide. So really broke the mold from the Las Vegas incandescent of the time. So here's a more prosaic example, right? This is an elevator lobby down in on 3rd Avenue here in Seattle, 1111 3rd. It was an LMN project. And if we look at this, right, how many control zones might we have here? Well, we certainly want to have these controlled separately, right? We want to have these downlights controlled on their own because they're doing a different function. The light behind the security desk here grazing the wall, well, there's nothing else quite like it, so that's a control zone. The 3-form panel here glowing on its own, that wants to be a control zone. What about the elevator cores here, right? So you'll notice this is a wood wall. This is a textured white wall that's not entirely dissimilar to this. The texture is a little bit different, but it's a similar kind of thing. So we actually had designed this so that these would be separate zones. So you'd have zone, these would be one zone, and then this would be a different zone. Now you could actually say there are 3 sets of elevators here. You could say that we would need 2 control zones because we could tie this one and this one and this one together, or you could have 6 control zones, however you want to do it. But ultimately, this got value engineered out. It became a real problem that lighting this wall and this wall with the same intensity from the light fixture really became a visual issue, and it was an unfortunate value engineer, let's put it that way. We won't go any further with that discussion right now. I hope this makes sense, right, with respect to how you want to think about control zoning. If I see one real mistake that people make, it's in trying to, quote, optimize a circuit so that they have more light fixtures on a control zone than they really should. If there's ever a reason you want to control things potentially separately, put them on a different control zone, right? Okay, so I talked about 3 sort of legs of this fundamental lighting control stool. So we had the power circuit, and then now we had the control zone. The third is what we call a scene or a preset or a look. And there's going to be different sort of words to use this depending on whether you're from architecture originally or theater or what part of the country you're in, but it's basically the same idea. So a scene is essentially a predetermined collection of zones, right? So in this particular case, right, I have a bunch of different control zones. My scene would be choosing to have each different control zone at some dimmed light level, right, so that I balance the whole thing together, and so that it's programmable and repeatable, right? So you might see that in the same kind of example of this sort of high-end boardroom teleconferencing kind of suite, where you can see that just varying the lighting according to dimming can be very profound. So it's repeatable. You really want to be using dimming now. You don't want to be using switching anymore because everything we use is dimmable. And you want to have something that we call a fade rate, right? So if you have light that changes, it's a problem. It's sort of jarring to you. If you have light that changes slowly over time, say 30 seconds, you don't notice anything's happening. So how does that sort of tie into some of these things? Well, we've all been in this restaurant, right, where we've seen a bank of preset controllers like this, right? This is a preset control system. We get a bunch of wall box dimmers, right? Where, let's say we're in this particular restaurant or bar, and at 5 o'clock in the afternoon, somebody comes over and starts fiddling with the lights, right? Now, you may be enjoying a, let's say, just happy hour libation with some of your coworkers in the before time when we could, do things like that, and hopefully will again in the future. And somebody starts fiddling with the lights, right? Something like this. This is hard. Something surprise happens, right? You get sort of jogged out of whatever it is you're talking. You're talking about the day. You're talking about your kids, whatever. Something happens, right? So this kind of forces you to look up. And then what else happens? Well, you're probably going to look down at your watch, and the next time that somebody comes by and says, "Would you like another round?" you're probably going to say, "You know what? I got to get going." Right? So from the perspective of the original rationales for using lighting controls for some of these things, one of the key ones was productivity, right? Well, how would a bar owner talk about productivity? Well, their productivity metric would be how many drinks were sold, right? So I would argue that having a controller like this in your bar is probably going to cost you money, right? If that makes sense. All of these things kind of come through, whether we're talking about a scenic controller like this, or we're talking about daylighting controls. Anytime you notice something's happening with the lighting control system, it's usually a bad thing. It should be beyond your notice, right? All right. So in practice, how does this work? This is the Semiahmoo Resort up in Blaine, Washington. And this is one that we did a few years ago. And you'll notice that there's a lot of daylight and there's a lot of different accent lighting in a variety of different places. We have a number of scenes in this particular place, right? We've preset it so that there is a morning scene for people to come in and set things up, clean up. There is a mid-morning scene based on the available daylight. There's an early afternoon scene based on the available daylight. There's a late afternoon, evening, nighttime. So the scenes change to direct your attention to a variety of things, but they also change based on the availability of daylight, the direction of daylight, where daylight might be coming from, and how you want people to perceive this space, right? So the idea is this is completely automated, right? There is an ability for the staff to go in and override things, but basically it's all set up on a time clock, and it's set up with, I think the fades were 1 minute, so that you just don't even notice over the course of a minute that something is changing, so that during the day the staff doesn't have to do anything, nobody notices anything. Very hunky-dory. Okay, I hope that all makes sense to everybody. Now we are going to have a brief pop quiz. You didn't realize there were going to be pop quizzes, did you? Well, so what are some of the reasons that we might want to use advanced lighting controls? Are they flexibility, user satisfaction, increased productivity, they add complexity to the project, maybe it's energy savings? What do you think? What are some of the reasons that we might want to use these control systems? All right, give you another couple of seconds here. And let's close and share the results. So how do we think here? So 60% of you think flexibility, 10% user satisfaction, 10% increased productivity, 20% energy savings. And the fact is that all but adding complexity are in fact correct, as one might surmise. It really, which of these becomes paramount really depends on what your project is, right? It really also depends on what the owner and what the end users really value. So there are, of course, others, as I mentioned, But you really kind of want to, when you're thinking about these things, want to get some kind of sense about who your users are going to be, who your owners are going to be, what their value proposition might be, and really tailor the discussions appropriately. I hope all that makes sense. All right. Excellent, excellent, excellent. Thank you all. Let me go ahead and close that out. Let's change gears a little bit. We've talked about some rationales for why we might want to use lighting controls. Oh, I should also point out, I'm sorry, I haven't enunciated this. If you have questions, go ahead and type them in, and at these kind of poll breaks, I will go ahead and answer them, or I might sort of stop in the middle and answer them as well, depending on what the particular question is. I didn't mention that because I don't see any questions here with respect to the class, but please feel free to go ahead and ask them if you have them, and I will answer them when I am able to. Okay. All right. So again, we've talked about the three key elements with respect to lighting controls. We've talked about some of the rationales. Let's talk about some of the strategies that we might use. Now, one of the things to really pay attention to here is that none of these strategies are new, right? I've been teaching lighting controls classes in one form or another for literally 30 years. And every single one of these strategies has been around for that entire time. Now, whether or not we had the ability to really implement them effectively or cost effectively or well is certainly up for debate. However, the concepts are not new. We will talk about some new concepts in just a little bit, but also bear in mind that these kinds of strategies, they kind of add on to each other, right? It's not a one or another. So in this particular photograph that we see here, the San Francisco Public Utilities Commission headquarters, this is a 14-story office building in downtown San Francisco. At one place or another on this project, every single one of these control strategies is employed. And that's not uncommon. You're going to find that you're going to have major overlap in a lot of cases. The good news is that network lighting controls handle all of these easily, and there is the ability to mix and match and change over time as we need to based on some of the hardware. Okay, so manual switching. Well, we all know about manual switching, right? You press a button or you flip a switch and lights go on, lights go off. That might be power handling with line voltage. It might not be power handling. It might have low voltage relays somewhere, right? The thing is, most of the time, I don't recommend people do manual switching anymore, right? Most of the time, the light sources that we're talking about, they're LEDs, they're inherently dimmable in almost all cases for specified lighting. So really, we should be talking about manual dimming, right? So manual dimming gives you the ability, whether it's, again, a power handling device with line voltage, or it's remote control to a dimming cabinet, or it's sending a signal to a dimming driver. We'll talk about that a little bit later. The idea is that instead of just being able to turn lights on and off, you want to be able to have some ability to go ahead and modulate the amount of light that you have in the space. This really does sort of come back to that notion of user satisfaction. It also comes back to flexibility, right? Now, we also can talk about scene or preset control, right? And this gives you the ability to have a device that, in this particular case, is looking at one of the Lutron sort of graphic eyes or a Pharos system or similar. And it's the ability to have a variety of different control zones that you can program, and then you can call them back either from the main unit or from some kind of remote unit, right? So it's repeatable, it's great and all that stuff. Now, it used to be that there was this continuum, right? You had to choose, you had either switching, or you had manual dimming, or you had some kind of scene preset. And if you're going to do the scene preset, you had to commit to, this $1,500, $2,000, in-wall unit to be able to do that. Well, as it turns out, when we talk about sort of network lighting controls, normally speaking, we're talking about a series of parts and pieces that all talk to each other, that are controlled today with some kind of level of programming, most commonly put together with an app from your smartphone or sometimes your computer, whatever it happens to be. But it really means that you can do all of these three elements with a relatively small kit of parts, right? So this is a little video that I put together here at stately Meadowbrook Manor. I'll give you a little bit. So here is let me actually pause this for a second. Can I pause it? I'm going to go back. Let's start again. Before I start the actual video, let me give you a quick synopsis. This is a lighting control board that one of the ones that I designed and built for this class that is intentionally made to look an awful lot like building wiring, right? So essentially, we've got a bunch of light fixtures. Think of each one of these as its individual control zone. Control zone could be one light fixture, or it could be a number of light fixtures. But we've got through wiring coming from, let's say this cord over here is coming from our load center, from our circuit breaker panel, and it comes into each box, and each box is daisy chained, right? So we have through wire from box to box to box to box to box, and then we go out from the box to the individual light fixture. So this is really what you would find in kind of a building, except writ small, right? So the biggest difference here is that this little bit of conduit is 2 inches instead of 10 feet. So piggybacked onto this, we have what we call load controllers. These are specific load control devices. They are accepting a signal from a lighting control system, and they are essentially saying turn on, turn off. They have a relay within them. And then they're sending a 0 to 10 volt signal, dim up, dim down, according to whatever the control system is saying. Now, this is one manufacturer's control system. There are 8 or 9 that we use in these classes when we do the hands-on components that can all do the same thing, and they can all do it well. So let's see what this maybe means a little bit here. So I've got a 2-button switch. So I am turning lights on, and I'm turning lights off. So if I want to, I can do manual control, right? Manual switching, up, down, just on, off. I can also, with the same system, with a very similar kind of wireless device, I can also do raise lower of a single zone, right? I'm turning it on, I'm turning it off, I'm dimming it up, I'm dimming it down. Turning it off. Then, from the same basic kind of device, I can turn on a whole scene, right? I can turn on a whole bunch of fixtures, and I can raise and lower the whole group if I want to. I can predetermine, I can decide which of these want to be associated or paired with each individual device, or I can set up complete scene control, right? So this is a 4-scene device. So there's scene 1, there's scene 2, there's scene 3. So instead of having to go and purchase, the $13 or $14 or $1,500 scene programming unit, now scene control or switching or dimming, it really is all about programming, right? You're going to have the initial devices anyway. So it's really all about choosing how you want to use them. Do you want individual switching? Do you want individual dimming? And most of the time, this is available wireless. You can do it wired as well, but it is what it is. All right, so I hope that makes some sense. Let's skip that. All right, so that's a little bit about the switching, dimming, some of the capabilities that you can get to. Let's talk a little bit about some of the other strategies, right? There, of course, is occupancy sensing. Now, occupancy sensing, we're all familiar with this, right? You walk into a space, the lights turn on, a certain period of time later, the lights turn off, right? separated from vacancy sensing. Vacancy sensing requires you to have a positive push on a button in order to have the lights turn on. Otherwise, the lights won't do anything. So it's the difference between manual on and automatic on, which is between them. Now, there are arguments, particularly with respect to usefulness and also with respect to energy savings for both. But the reality is, if you're going to use a sensor, use a sensor. In all but one instance that I'm aware of, the actual physical sensors are the same, and the difference between occupancy and vacancy sensing is entirely programming. We'll talk a little bit later about some ways that we can do tricks of programming for occupancy and vacancy sensing to actually make them work really well, but that'll be in the programming segment we go through there. One thing to think about occupancy and vacancy sensors is that most of them, at least for the modern systems, certainly all the wireless systems, they're all passive infrared. So what does that mean? It means that a passive infrared sensor is essentially looking for a heat signature across a number of segmented fields and movement across those segmented fields. So what does that mean in practice? Well, if the sensor can't see you, then it's not going to understand that you're there. Or said differently, if you can't see the sensor can't see you, so you're going to have false triggers off. In fact, a friend of mine in Idaho just moved to a new office last week, and she said that lighting was great and all, but that the occupancy sensor keeps timing out on her because it's not seeing her, right? And I said, well, that's great that it's not seeing you. That's good understanding, because she had these sensors that were mounted in the wall, right? So if you have a passive infrared in the wall and then you put something in the way that you can't see, it can't see you, like a toilet stall, for example, or a bookcase, that becomes a problem for it, right? So passive infrared, looking for movement, it can be battery operated, right? It can also be powered by convenience power or by low voltage from a relay or something like that. But most of the time with these kinds of systems today, they're mostly going to wireless battery operated, which 10-year battery life. Okay, occupancy sensors, other type, right? The other option for most sensors is ultrasonic, which means that it's essentially emitting a high frequency ping and it's waiting for the return back from that ping. Well, this is great because it can see around things like toilet stalls. Might have some problems with airflow, but one of the key problems with it, because it's an active technology, it actually consumes energy, consumes electricity, so it can't be battery operated. So if you want to use ultrasonic or dual technology, which is the two of them together, then you need to have electric power, right? You can't just assume the battery, because a battery will just degrade all that too much. Okay, so the key thing about these things that I see people sort of making trouble for themselves with is not understanding coverage area. So each one of these systems will have, or sensors will have in the cut sheet, a graphic that looks awfully much like this, right? So you'll see that there is two gray bars here, right? This is what we call close-in motion or fine motion, right? It's this kind of motion, right? I'm typing at a keyboard, and then we might have the gross motion, which is the big motion. I'm moving physically around. So how you overlap those things, how you overlap the sensors matters, right? And where the sensor is looking from matters. So as we talked about, if you put sensors in the wall, right, this is a very popular, or has been a very popular way to put in occupancy sensors, because if you've already got a switch leg going down the wall, you just have to go ahead and replace the toggle switch. So it's great for retrofits, right? But the problem is that it frequently has difficulty seeing people. If you're going to run into that, go ahead and put in one of these ultrasonics rather than a passive infrared. I normally prefer passive infrared for some reasons, but if you're going to have a situation like this, go ahead and use the ultrasonic. Even better, go ahead and put them up on the wall high, like in a classroom, right? so that you can see a higher percentage of the room. Or even better, my favorite choice, put your sensors up on the ceiling. When you put things in the ceiling, they can see basically the entire space, right? That's important. I will say that it took me a while to really warm to the idea of battery-operated sensors, but I showed you that San Francisco Public Utilities Headquarters project. That was completed in 2012. That was the very first project that I ever designed that had nothing but battery-operated sensors. And actually, it worked out so well that that's pretty much all I use anymore is battery-operated, right? The amount of pipe and wire that you save is huge. Also, the ability to quickly and easily shift things around if necessary. You know, the sensor is 2 feet too far that way to pick everybody up. Great, move it, not a problem. Or add another one. These things are not expensive. Stick another one up into the ceiling, pair it. It takes 5 minutes to program it to the system. That's why I kind of like these sensors. All right, so that's occupancy and vacancy sensors. What about daylight harvesting? So we have this idea, right? We have abundant daylight in the space. We want to be able to dim the lights, dim, 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 never switch anymore. Dim, 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 dim. The lights according to the amount of light that's available. If we had more time, I would tell you a great story, maybe later, maybe tomorrow I'll tell you the story about the Unum Corporation up in Maine. So daylight harvesting, we're using a photocell. There are a few things to think about with respect to this, right? So you can have what we call open loop sensor systems, which basically means that the open loop, the sensor is looking towards the sky, towards a window, through a skylight. Essentially, think of this as a broad brush, right? It's not as fine-tunable as the closed loop, but it's very easy to commission, right? It's always kind of looking outside. It's sort of the big ship of daylight controls. It kind of slowly makes some changes. So here's an example, two examples, in fact. This is the University of Montana Rec Center over in Missoula, where we've got the sensors up in the ceiling here, up in the skylight well. This is actually King Abdullah University over in Saudi Arabia, or similar kind of thing. This is the library, and we've got the sensor up here in one of the ledges, looking up, one of the I think it's ledges, looking up at the skylight there. And the idea is that because they're always looking at the same place, they're getting the same input over time. Great. So why does that matter? The other way to think about daylighting control is closed loop, right? So you have a sensor, it's either on the light fixture, maybe it's on the ceiling. If you've got indirect lighting, you absolutely want to bring the sensor down to the level of the fixture, because otherwise it's going to be getting light from the fixture itself, right? That's what this graphic is showing. Essentially, it's looking at a work plane, and you program it in such a way that if you have your work plane here, you calibrate it according to how many foot candles or lux are on that plane at any given time, and then it tries to maintain that light level over time. That sounds great, right? What happens if I am working on my plane here and I've got a desk and I've got, when I'm calibrating it, I've got a bare desk, but later on I have white papers all over my desk, or later on I have, you know, let's say black books all over my desk. That's going to change what the system is reading, right? What happens if at one point I have a desk here, and then at a different point that desk moves, and then I've got a dark carpet underneath, right? It's going to be a different calibration. So this changes, this makes it a little bit more finicky, right? So there's nothing against closed loop sensors. And in fact, the best of all worlds is systems, I think, that have both, right? A number of manufacturers kind of take a closed loop look and an open loop look out the window and kind of average the two, do some kind of voodoo. But I hope that's kind of clear. The time that this is a little bit different is when you actually have systems that are luminaire level lighting controls where you have a lot of different sensors. Then closed loop is actually good. We'll talk about those as we move forward. Okay. So next one is test tuning or high-end trim, right? So that's the idea that as lighting designers, we've all been taught to overlight spaces for a variety of different reasons. The number one reason is so that we can compensate for what we call lumen depreciation, right? So that over time, all light sources degrade. They'll put out less light as they age. There are other, we call them light loss factors, right? Dirt depreciation and some others. There's also, frankly, let's just say most designers will add in a little bit of fudge factor because there may be last minute changes to architecture, right? So if I really design a close system and I'm assuming that I'm going to have a 90% reflective ceiling tile because that's what the construction documents show, but then later on the site, I find that they've value engineered that to a 70% reflective ceiling tile. Is that going to have an impact on the lighting? Yes, indeed. What if they've gone from a floor that's like this, that's relatively reflective, to a dark carpet? Well, that's going to have an impact. What if they've gone from a white wall to a dark blue wall because that's the corporate color? Well, that's going to have a big effect, right? So typically a lighting system new out of the box is somewhere between 20 and 30% higher light level than it actually needs. Task tuning or high-end trim basically means you go ahead and from day one dial it back so that you dim the lighting system down to the target light level that you were aiming at anyway, and that can save as much as 20 to 30% of the energy right off the bat. Over time, you're probably going to want to come back in 3 years, 4 years down the road, bump it up a little bit, but over that whole time, you've been saving a ton of energy. Now, there's another type of task tuning called adaptive compensation. Now, the idea here is thinking from sort of human visual perception at night, and this is very broadly speaking, we need less light than we need during the daytime. Why? Because our eyes are adapted to the darkness. Think about this. You're in a movie theater, you walk in, the lights are up, you can read the program. The lights go down, you can't read the program. 10 minutes later, your eyes have adapted to the lower light level, you can read the program again. This is kind of what we're making use of. So we did a project, lighting lab and integrated design lab with Whole Foods a number of years ago in the early 2000s. And with Safeway as well, demonstrating for them that they could save, again, another 30 or so percent of their lighting interior at night and make for spaces that were more comfortable for people. The Safeway manager that I was working with, I think he was actually the Safeway CEO, was in for the meeting. Wasn't really thrilled when I told him that I referred to this idea of the Safeway squint. There was a Safeway up on Broadway in Capitol Hill where if you walked in, it was so overlighted at night that it actually hurt you for the first 5 seconds as you walked into the space. That was all wasted energy, right? The only usefulness for it there was to hurt my eyes, right? So this is one sort of key area that you can use adaptive compensation. Time scheduling, we all know about time scheduling, right? We have the ability to turn lights on, turn lights off according to some schedule. I will tell you that this is much less common now in buildings than it used to be because more and more areas require occupancy or vacancy sensing. So unless you're going to use time scheduling in conjunction with occupancy and vacancy sensors, and we'll talk about that in programming, you really tend to see most things being governed by sensors, except maybe large areas or lobbies, places like that. Special case, astronomic time scheduling. So astronomic scheduling basically means you take the longitude and latitude of your space. For Seattle, that's 47.6 degrees north by 122.3 degrees west. And the system will calculate every single day sunrise and sunset. Why does that matter? Well, if you've got exterior lighting, facade lighting, whatever it happens to be, if you want to have all of the lights come on or all of the lights go off according to the availability of daylight, this is a great way to do exterior lighting so that you don't get into that whole issue of having a multiplicity of photosensors. You might have a bunch of pedestrian poles, each one that has its own photosensor. And then for, the space of about 45 minutes every night, they'll come on at different times, and it looks really, really lovely. This is a much easier way to do it. Coincidentally, this used to be really, really exotic. You used to have separate devices that would actually do all the calculations for you. Now, every single lighting control system I'm aware of does this just automatically because it's a trivial calculation. Right? Okay. Load shed. A load shed or demand response. This is another one that another control strategy. This kind of came into its own during the Enron days, particularly the California brownouts. Although I suspect, given the recent events in Texas, this is probably going to become really sort of interestingly thought of again. But it's also being considered in a lot of different locations, including here in the Pacific Northwest. Not as much for grid stresses. It was really initially put together for grid stresses during the California brownouts from Enron. But if we go ahead and make use of information from our electric utilities that are telling us about power fluctuations based on the wholesale market, and when those fluctuations are occurring, maybe the energy from 6 o'clock to 8 o'clock at night is the most expensive, right? So then the utility can send a big user a request to cut their load. If we've got a large area lighting control system, we can go ahead and reduce our energy use by a certain percentage, still allow us to use our space while providing 20, 30, 40, whatever it is percent diminution to the electric utility, right? The first project I'm aware of in Seattle that had this was actually one that I designed, which was the Amgen Helix campus up on Pier 90. And it was fully brought online in 2004, 2005. The reality is at that time, we used something called SneakerNet, right? So the utility, in this case, Seattle City Light, would call a building operator and say, we need you to reduce your power, hit go, right? So then the building operator would go over, hit their control console, and then dim the lighting down accordingly. As it turned out, I don't believe that was ever used here in Seattle, but I suspect that's sort of coming. Now we have the idea of things like OpenADR and others, which is the idea that we would have automated response, right? So utility would send out a signal to all of the various big power groups, and that would go ahead and spark a response. Okay. Bi-level switching. Bi-level switching is a strategy that was really popular when we had fluorescent and ceramic metal halide. In fact, that original Reebok World Headquarters basketball court would be a case of quad level switching, right? But I still have people asking me about how to implement bi-level switching in the world of LEDs. They're all dimmable. Dim everything. Don't switch anything anymore. Bi-level switching. Don't do it. Don't do it. Don't do it. It's more costly to do bi-level switching than it is to do dimming. Just don't do it. All right. So those are the sort of older control strategies, right? The ones that have been around for 30 odd years. The newer control strategies are some interesting ones, and they're predominantly based on the idea of how we can effectively use LED light sources, whether they're colored LEDs or whether they're specific for tunable, whatever they happen to be. But there are a number of examples. This is one over at Children's Hospital, did a few years ago. We had originally intended to kind of do a circadian system at Children's Hospital for both the patients as well as the staff, but that proved to be extremely expensive. It's not extremely expensive anymore, right? This was done, the design was 2010. So the cost was extraordinary then. What we did manage to get in was this wall slot here, where we have this color tunable LED graze light down. It's a little bit hard to see with all of the daylight here, even though it's a fantastic view, right? But the idea is that the child has the ability to change the color of the graze light here to whatever they want, right? They have a bed controller. So that basically just gives them another opportunity to be able to go ahead and have something to take their mind off the fact that they're sitting there, recovering from whatever they're recovering from, right? This is a good thing to be able to allow them to do. So what are some of these strategies? Well, color selection, right? We just saw one. But the idea is that we have multiple LED chips with different colors that we can mix and match for different purposes. This is one of the cubes over at Microsoft, over at Building 17. This is an internally illuminated, it's essentially a glorified staircase, right? The idea is that it encourages people to do active vertical circulation rather than going to the elevator core. It's pretty cool. But we can essentially turn these cubes into whatever color that we want with this internally illuminated LED system with Barrasol screen. If we talk about predominantly white light, we have two real things that we can talk about, right? One is tunable white warm dim, which essentially means that you have a couple of different chips on board in your light source, so that you have a warm chip and a cool chip. And as you reduce the power to the light source, typically from a phase cut dimmer, it dims towards the warm, just like an incandescent would, right? If you take an incandescent lamp, you have it at full output, it's one color, 3000 Kelvin, 2700 Kelvin, whatever. As you dim it, the filament cools, it shifts to the red, and it gets warmer. It gives us that really nice warm glow that we really like for residential and hospitality. Well, LED sources naturally don't do that unless you have them set up this way, right? But warm dim is one opportunity for that. The other is tunable white, which operates essentially the same kind of way, right? You've got a warm and a cool board or cool chip, and you might have some intermediates in the middle there as well. But the idea is that you have the ability to essentially mix and match to get to a variety of different color temperatures or spectral characteristics along what we call the black body curve. If any of this is unclear to anybody, please go ahead and go back to the Lighting Design Lab education page and look into the light and human perception class. A big discussion of all of this is to be found there, and you can sort of bring yourself up to speed on it. But the idea is that we would use these things to affect mood, affect our endocrine systems for our circadian systems and so forth, or sometimes just for aesthetic reasons, right? And we see these in offices, right, where we can go ahead and pick and choose what color of light we want, right? Do we want it warmer? Do we want it cooler? To a certain extent, that is a personal choice, but to a certain extent, it also has some impact on our endocrine system based on the spectral power distribution inherent in the light source, right? And if you go ahead and make use of a lighting control system, you can potentially engage in some behavior modifications. This is something that's really, really of interest in schools these days, right? Or you can go ahead and add a time clock, essentially, and you can wind up having specific effects on, like I say, your endocrine system, your sleep-wake, serotonin, melatonin cycle. Now, I want to be clear. The research is still out with respect to both the behavioral effects and the physiological effects of some of these things. There is a growing body of evidence that suggests that we can go ahead and affect our hormones, our endocrine system with respect to lighting and lighting controls. One key thing here, however, is that it's not just about color, right? It's about color, it's about intensity, it's about direction, it's about duration. It's very complicated. This is not sort of a class that talks entirely about that, although we will have one of those coming up. So if you're interested in that, let us know. We'll jump in further about that. Suffice to say that there are 5 or 6 different variables that people talk about with respect to circadian lighting. Lighting controls can modulate all but one of them, right? So important stuff. Okay. And of course, there's architainment, right? We'll talk extensively. We'll talk about that. But these control systems allow you to do all kinds of cool, groovy things. All right, so let's switch gears just a little bit again about some of these things. So we've talked about some of the strategies, some of the rationales, the basics. Let's talk a little bit about hardware, right? When we're talking about lighting controls hardware, very frequently, if I ask the question, of you folks, how many people have heard complaints about lighting control systems? Everybody's hands would go up, right? How many people have heard complaints about occupancy sensors not working? Everybody's hands would go up. I would submit to you that a big part of this has to do with the evolution of the hardware, right? We started out with this mad scientist with his knife switch there, right? And we've gone through switches and contactors and dimming systems and zone systems and PoE, power over Ethernet. And now we're up to the Internet of Things, right? But ultimately, what we've got here is the evolution from analog to digital. And we've seen this in every single device that we have, right? 15, 20 years ago, I had a Crackberry, right? And I was one of those people who you'd get off the plane and I'd be thumbing my way through my email, right? That was not a great device. It was a great device for the time, but it paled in comparison to the devices that we have today. A little bit before that, I was lucky if I had a cell phone that sounded like I wasn't in a fishbowl, right? So all of our devices, whether they're lighting controls, building controls, toasters, whatever it happens to be, the hardware is tremendously better than it's ever been. So I would submit to you today that in almost all instances, if you have an example of an occupancy sensor or similar that's not functioning properly, it's probably bad design. It's probably because there's some problem with the way it's been set up or the way it's been installed or where it happens to be. It's probably not the device itself. So take that as written. So we've talked about a whole bunch of strategies here and these kinds of things. How do you keep it all straight? I like to use matrices, right? So this is an example of a typical strategy matrix that I might have. And when I was in private practice, I would actually have one Excel file that looked like this, that had essentially every typology of project or space type that I'd ever designed. And it would have these kinds of bars written in them so that I could just grab this entire Excel file, throw it into a basis of design document, and then just delete the typology spaces I didn't have, right? If I was doing a school, I would get rid of boutique retail and get rid of big box retail, get rid of boardroom. I'd probably have cafeteria, I'd probably have circulation, I'd probably have classroom and conference. So it makes it a really easy way to, rather than reinventing the wheel every single time, you kind of have a good way to quickly and easily quantify what it is a lighting control system is supposed to do, right? All right, this is another good time for another pop quiz. What are some of the key strategies, key control strategies that we might employ? Might be daylight harvesting, vacancy sensing, time clocks, task tuning, turning down thermostat. What do we think? What are some of the key strategies we might employ? All right, most of you have voted. Let's kill this and share. So, as it turns out, one of the key controls, so turning down the thermostat might be a key control strategy for a smart building system. It's not for the lighting control system, but that's an interesting sort of tie-in because lighting control systems are really becoming more and more integrated with within the smart building ecosystems than they ever have been before. But these for daylight harvesting, vacancy or occupancy sensing, time clock or scheduling, task tuning tend to be thought of as the four principal lighting control strategies. The rest kind of either depend from them or they are some variant on them or they're just not quite as common, right? These are the big four. So very good, very good. And I'm noticing there are no questions so far. So again, reminder, if you have questions, please go ahead and type them in and I will address them as I can. Seeing no questions, I am going to push forward. Okay, let's hide this. All right. So let's spend a few moments talking about dimming, right? I've mentioned to you that basically all light sources that we're using today are inherently dimmable, right? LED light sources paired with dimming drivers, which basically all commercially available lighting is one way or another dimmable. Now, there are a few outliers, but for the most part, it's important to understand a little bit about what that means. We're not going to go into the nitty-gritty too far here, but let's sort of start to think about that, right? Everything is dimmable. Well, how did that start? If we went back into the old days, we would, find in theater, because basically everything to do with lighting controls started in theater one way or another. The original dimmers were essentially big tubs of salt water, right? There would be a cathode plate at the bottom and a cathode plate at the top. There'd be wires going to each of them. And if I wanted to have the lights brighter, I would have a stagehand who hopefully had very good life insurance plunge the plates closer together in this saltwater bath. The closer they got together, the more current would flow, the brighter the lights would go, right? So this was kind of a very analog way to think about this, right? Pull them further apart, there's less current flow, the lights get dimmer. Very simple. Fast forward past half a dozen other technology improvements, and we came to the 1950s. A fellow named Joel Spira in New York came up with this idea of using semiconductors for dimming in one's house, right? So the very first triac controlled or semiconductor controlled wall box dimmer was from 1959 from a small company called Lutron. This is a picture of it, right? So the idea is that you have devices that switch power on and off a certain number of times per second. When they turn the devices on, when they turn the power on and off, and how many times they turn the power on and off, determines how much energy is going to go, in this case, to a filament, right? So then that filament will glow either brighter or less bright. Now, if we jump forward a little bit more, we had this idea in the 1980s called IGBTs, insulated gate bipolar transistors or field effect transistors, and they're doing the same thing, just a little bit smarter, a little bit better. And these both kind of referred to as phase cut dimming. So how does this work? In the triac or silicon controlled rectifiers, we call it forward phase cut. So basically, the power is off, off, off. So this is a sine wave, right? So electricity, you can represent it as a sine wave, forward, backward, forward, backward, forward, backward, electrons moving, right? So they would do this 120 times a second because that's how our power is delivered with a 60 hertz or 60 cycle. So 60 times forward, 60 times back. So each one of these happens 60 times a second, but each half wave happens 120 times a second. So you're turning the power on and off 120 times a second. I hope that makes sense to everybody. So in the forward phase cut, you have the power off until a certain point in the wave, and then you turn it on. So this is probably, let's say, 40% light output, right? So off, 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 on. If I wanted 50% light output, this is probably 60% light output. If I wanted 50% light output, I'd be off, 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 on, right? Now, what happens when you turn an electric circuit on, there's something called inrush, right? So instead of this pretty little sine wave here, it would actually overshoot and then come back. overshoot, and then come back. That led to things like that nice 60 cycle phase hum that we would hear from filaments, because what they're doing is actually oscillating, right? It's forcing them to oscillate. So this works, right? And this is still the basis of most wall box dimmers today because it's relatively inexpensive. Something called reverse phase cut, though, makes use of those insulated gate bipolar transistors or field effect transistors, and it takes the power and what we call soft starts it, right? So it starts from 0, slides up, comes on, slides down, comes on. It's more expensive. It's better for the system. There's another way that we think about this, which is called pulse width modulation, which essentially means instead of 120 times a second, you're turning the power on and off multiples of that, right? And this ultimately leads to a look of something that almost kind of looks like a filtered sine wave. It really starts to make the sine wave look like it is being reduced rather than turned on and off. Let me show you a quick demonstration here. So this is an oscilloscope that we had at the lighting lab. And this is an incandescent dimmer, which is the same kind of technology that the Spiris put together. And you'll see that it's snapping on, going further than that. And then as it comes up, you see that waveform start to establish. Right? So that's the off, snap on, off, snap on. This is the reverse phase, which is sliding on, right? Soft start. And you'll see that starts to establish the sine wave there. And the last one we have there is actually pulse width modulation. So you'll see that it actually appears to adjust the amplitude of the sine wave because it's cutting it so quickly. Most of the time when we're talking about screw-based LED light sources, they're phase cut modulation, either reverse or forward phase. When we're talking about native LED light fixtures, they're usually, not always, usually pulse width modulation because the dimming is actually occurring in the driver itself. So how does that work? Let's jump past this. So, a quick history of light sources, however, and this is going to be very quick before we dive into that whole bit. If we were talking about this class just a few years ago, we'd spend a lot of time talking about all these different light sources. But the reality is, they're all legacy light sources at this point. So we're not going to spend time today doing that. If you're interested, we can talk later offline about some of these other light sources, whether they're dimmable, whether they're not dimmable, how they dim, yada, yada, yada. But the fact is, realistically, we're talking about LEDs, right? We've talked about this a little bit. Solid state light sources, flexible, long life, all these things. None of this should be news to anybody. But the impacts are huge, right? The biggest impact for us is that we have better fixtures, not better fixtures, we have smaller fixtures with better optical control, but we're dimming, right? Dimming, 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 dimming. There's also some potential confusion there, right? So as I mentioned, LED lamps, right, the screw-based lamps, they'll come in a variety of different shapes that kind of emulate what we've all expected from incandescent or metal halide or some of these different shapes. But these will all be controllable or mostly controllable based on the phase cut dimming, the wall box dimmers that are actually using the power handling. Native LED light fixtures, however, will actually be all about the driver, right? So you'll have a light source that looks, a variety of these different shapes, different configurations. And then there'll be some kind of power supply, right? This is a switching power supply, not entirely unlike the switching power supplies that we knew as electronic fluorescent ballasts, right? They're doing things, the physics is a little bit different, but it's important to understand that there are a couple of different types, right? You can have constant current or you can have constant voltage drivers. We're not going to get too much into them. Suffice to say, however, that there are different types, and the different types of drivers, some will allow you to dim more deeply than others. Some will give you more of an opportunity to see flicker from the LED light sources than others, right? So if you are using something that is really has to have low flicker or no flicker, you're probably using a constant current reduction, right? That is not, however, going to allow you to achieve very deep dimming. Now, this is not, it's not really important for you to know the details of these right now. This is a little bit beyond the level of this particular class. Understand that there are differences in drivers, and understand that you are going to need to work with your manufacturer to pay attention to their dimming curves and how they are allowing dimming, and also ask them questions about flicker. Also, in particular, go ahead and ask for samples. If you're doing big projects, get samples. Try the fixture with the dimming system. Make sure that that's not happening, right? Make sure that the flicker is acceptable to you, whatever level. So what is flicker, right? All light sources will flicker. Every single light source you can name, including incandescent, will flicker unless it's being powered by a DC source, right? Now, we can think of flicker in two ways, right? There is what we call amplitude, and which is how much is it flickering, and there's frequency, how fast is it flickering, right? As it turns out, the flicker in incandescent typically doesn't matter because the amplitude is relatively low, right? The change doesn't happen as much. And the frequency is 120. When we were talking about magnetic fluorescent, it was significant because you could see the flicker, and it was very annoying. It would happen at 120 times a second, and you could see all that stuff. LED, you can actually see flicker in a lot of LED light sources, and it can become a problem. So in a lot of ways, you get what you pay for, right? Low-cost drivers, low-cost systems tend to have more potential for flicker, right? So we understand how to deal with these things, just like we did with fluorescent. Increase the frequency, so higher the frequency, the less likely you're going to perceive it. The amount of amplitude or modulation, you don't have as much capability with respect to the LEDs because they're switching on and off. That's just part of their deal. So if you really want to still have this kind of low-level dimming capability, but you want to avoid flicker, you're going to need to have a driver power supply that goes up in this range, right? I hope that makes sense. Now, there are a lot of ways that we can review flicker, right? Some of you may have things that look an awful lot like this, right? This is a flicker checker that we used to use for fluorescent ballasts, where you spin it and you look for stroboscopic effects on the wheel here. You can also find stroboscopic effects with your phone. If you take your phone, point it at a light source, put it in a video record mode, and sort of scan it back and forth, if you see scrolling lines, that's going to be perceptible flicker. That's something that we call refresh rate mismatch, right? So, all right, pop quiz here. What is doing the actual dimming in most LED light systems? Wall box dimmer, 0 to 10 volts, LED driver, a clapper, or magic? While you're doing that, Alicia asks, how does a dedicated neutral affect phase dimming? Is it recommended for LEDs using phase dimming? Alicia, that's an excellent question. So there should be, if you really want to have the best performance from a wall box dimmer, you want to have a neutral pulled to it, right? And there is some discussion of this. I've had some discussion of this over the years with contractors. Some of them tell me that it's not required by NEC. Some of them tell me it is required by NEC to have neutrals these days. I believe it is required. I could be wrong about that. I'm not an electrical engineer or a contractor. However, what I do know is that if you want to have reverse phase control, high quality dimming, you need to have a neutral. And part of that is that the neutral to the box allows the dimmer to actually properly sense when the zero cross of the sine wave is happening. That's a really detailed answer, which could be distilled down to say, yes, bring a neutral whenever you possibly can to a box. All right. So, share this. What is doing the actual dimming in most LED systems? It's the LED driver in most LED systems, unless we're talking about screw-based systems, in which case the wall box dimmer itself is doing the actual dimming. So the driver and magic, of course, is actually a good answer as well, because sometimes it really does seem like magic. The 0 to 10 volt is one of the protocols, which is a good lead into. Oops, I have to hide this. All right. So, so if the LED driver is doing the dimming, right, and the wall box or whatever front end, whatever device that we're actually going to be interacting with is not doing the dimming, all it's doing is telling the driver what to do, how do we communicate that, right? Key thing here is dimming control protocols, right? There are a number of essentially languages that various devices speak. By far the most common these days is 0 to 10 volt, right? So 0 to 10 volt is an analog signal. And essentially, as the name would suggest, you have two wires, and the potential between the two will determine whether something goes up or something goes down or stays in steady state. It's very inexpensive and it's ubiquitous. We used to use it a lot for fluorescent. We kind of stamped it out almost for fluorescent in favor of digital systems for a variety of different reasons, but LED has kind of brought it back. So this is the key one. It works well. It's imprecise, right? If you have a field of 30 light fixtures, you might be able to see slight variances between them. So if you need precision, or you need something that is able to be more controllable, architainment or color tuning, these things, you might look at DMX 512. DMX 512 is a theater standard. It was promulgated in the early 1980s. And hasn't changed an awful lot since then. Some minor changes here and there, but for the most part, it is. Key thing with DMX as a sort of protocol is most of the DMX systems out there require wiring. Most of the 0 to 10 volt systems, most of the wireless systems are usable with 0 to 10 volt. So those are some key things. If you want to learn more specifically about DMX 512, well, I was about to tell you where to look, but I don't know where to look yet. We recently did a class, the IES, on DMX specifically, but I don't know where that's going to be stored yet. So look for IES Puget Sound or IES Seattle, and I believe it will have that posted at some point. Okay. Another one, DALI, Digitally Addressable Lighting Interface. This was very popular in Europe. It's an open standard, and it allows for digital control. So you actually have each individual light fixture is its own unique address, and never really got popular here in the US, except as, oddly enough, some of the proprietary standards, which Lutron, for example, their ecosystem was originally based on DALI, right, with some twists. That gives you that whole notion of proprietary. So that's how, some of the ways that the systems communicate with each other. Okay, that's the language. Then how is the communication done? For the most part, we're talking about wireless systems now. You can also, all the systems basically allow you to do wired as well, or most of them. But the dominant thing that I'm seeing in the industry is that we've gone to wireless. So we're doing that with Zigbee or Bluetooth or an Ocean, a variety of different ways. And the big reason for that is that it's less costly, right? If I don't have to run pipe and wire down a wall for a wall switch, that's a huge savings. In fact, I did a quick bit of math with a couple of contractors, and the break-even point for how long it would take to equal the cost of switching out batteries versus the cost of upfront bringing a switch leg down a wall is something like 40 years. So you'd have to be replacing the batteries in the device for 40 years before you'd actually equal the cost of putting in the wired system. So that's a big thing. But you got to pay attention, right? There are a variety of different ways that these can be configured. Star, cluster, mesh, sometimes talk to each other. Honestly, there are pluses and minuses to each of these, so I'm not going to talk about them too much, other than to say that each manufacturer will tell you that their way is the right way. And, there are, like I say, pluses and minuses. Big thing to pay attention to, though, is that you really need to think about radio signals, right? They're going to function differently in a gyp wall that has metal studs than they are in a concrete wall that has rebar in it, right? So think about laying these systems out much like you would lay out a Wi-Fi system, because it's functionally the same thing, right? It's radio frequency in the space. And you also have to pay attention to cybersecurity with these systems. Now, this is not unique to lighting controls. It's also not unique to wireless, right? Wired systems are just as potentially at risk as wireless systems. So pay attention to that. We'll talk a little bit more about cybersecurity tomorrow when we're talking about programming. All right, so let's round this out with a quick bit about some of the systems, right? Some of the hardware. So we've got lighting control systems, right? We used to think of them just as toggle switches like this. But if we step up from the toggle switch, right, we have low voltage relay systems. This is an example of the power circuit kind of control, right, where we have a pair of wires coming from a relay panel to each control zone, and that's it, right? So there's a lot of pipe, there's a lot of wire, there's a lot of space that gets taken up in the electrical closet, and it doesn't allow us to do dimming, so it's not really quite as interesting. Okay, what if we add dimming? Well, we come to this idea of preset architectural dimming systems, where we have a cabinet with dimming, basically a silicon-controlled rectifier dimmers in an electrical closet. It's the same thing, right? You have two wires, you have a home run pair for each control zone, takes up a lot of room, takes up a lot of copper, and it's frankly quite expensive. So it does give you the dimming capability, but unless you're doing something like theatrical, where you've got lighting control zones that have 1,000, 2,000 watts to them, it's not as really useful anymore as it used to be. Today, we kind of do this whole idea of distributed systems, right, where we have individual circuits that daisy chain from system to system to system, or from device to device to device. And then each device has its own level of logic that tells the light fixtures go up, go down, right? A special case of that, of course, is this whole dolly thing, where essentially every light fixture is its own individually addressable control zone. And then we have this notion of luminaire level lighting controls, right, where we take all of the fixtures, the sensors, the logic, all that stuff, and wrap it up into one package. Luminaire level lighting controls, really interesting. We'll talk about them a little bit more tomorrow in particular. But the idea is that they tend to simplify purchasing and installation because you wind up essentially having everything together. You have individual control zones. I'll talk a little bit about the very specifics about why this is interesting when we go through the homework tomorrow. Then, of course, there's power over Ethernet, right? So power over Ethernet is this whole idea of, instead of doing line voltage wiring, we do low voltage wiring with the ubiquitous Cat5 and Cat6 cables. So essentially, we go from a network switcher to a light fixture, and we're providing power and data over that Ethernet cable. There are pluses and minuses to PoE, right? PoE gives us a lot of data capability. It also doesn't have to be run by an electrician. However, you're right back to that whole idea of individual home runs rather than being able to do daisy chain. So it takes up room in a closet, takes up room in the ceiling for cable trays, pluses and minuses. If you're interested in power over Ethernet, this is not what this specific class is, but go to our Lighting Design Lab webpage, the educational tab, and you'll be able to find Armando actually did a class on PoE specific that will be able to go through a lot of the pluses and minuses there, right? Okay. All right, so however we're doing this, the whole idea is network lighting controls today, they're better, right? They're more complicated, not more complicated, they're more complex, but they're less complex, right? They're more capable. Interestingly enough, they're really much easier than they've ever been, and they're much less costly than they've ever been. We'll have some examples of that tomorrow as we jump through. Now, a key thing here as we kind of round out the day is that at the end of the day, we've got all this great hardware, right? We've got these systems. Somebody has to decide what is going to happen. Somebody has to put together a sequence of operations, right? How are we going to do this? Is that going to be the lighting designer or the electrical engineer, the architect, the owner? It could be any of these things, right? But the idea is, as we're putting these systems together, we're designing them, we're buying them, we're installing them, somebody has to decide what happens. What does that switch do? What does the occupancy sensor do? How does that all come together? We'll talk a lot about those tomorrow, about how we can go ahead and implement some of these things, how we can think about what these things happen, what these things do and how, right? I'm going to skip this pop quiz because that's out of order. And I'm not sure why that is. All right, so I'm also going to skip these. There we go. So here are some of the things that we would wind up doing with respect to the sequence of operations, right? And there are a lot of different places that we might document this kind of information, depending on the project, depending on how we're doing it, right? It might be in a matrix, like I showed you earlier. It might be a panel schedule, dimming schedule. It might also be some kind of text-based documentation. This is an example of the text documentation that I did for the private offices, typical private offices for the San Francisco Public Utilities project. Now, you can read through this yourself. You're not going to need me to read through it for you, but you'll discover reasonably quickly that it gives the installer and the commissioning agent basically all of the information that they would need for this particular private office typology to be able to program everything about it, right? Not leaving anything to chance. This is important. So putting together narratives like this work just fine. Putting together matrices like this actually work out really well also. The reason for that, I used to do everything by narrative. The reason I go to matrices now is because the matrices live on a set of plans. So when I'm designing a space, I want the end users and I want the maintenance people 10 years from now to understand what it was that I was planning for their space, right? 5 years from now, 10 years from now, the odds of someone being able to find the specification book that the narrative would be in, questionable. But they're certainly going to be able to find the set of plans that are in the plans office, and they'll be able to find that pretty easily. So this kind of information lives on there. So let me just give you a quick thumbnail of this. This is the matrix that I use now. Talks about the room number, talks about the control zone. So in the first example that I gave you, which was the classroom, this was a room controller, right? A, B, C, A, right? Room number 1, A, B, C. Room number 2, A. In the second example that I gave you, which was the WSU Troy Hall, it sets up zones like this, right? Room number 4, zone 2-12, zone 2-13, says what it is, says what the target light level is, talks about what the different types of control strategies there might be, and has some additional information. We'll talk about some of the additional information tomorrow. Now, you're going to have some homework here. I want to leave you with a little bit of homework. So if you haven't already downloaded the homework from the handouts, please go ahead and do that. You'll find an Excel file file that looks just like this, and you'll find a set of plans that look like this. This is Tech Offices X, right? So you'll have a plan, section renderings, all that kind of stuff. And the idea is that you've got this office neighborhood. This is Tech Office neighborhood. You've got an open plan office with a window wall. You've got a private office, a small conference room that we would call a team room or a focus room. And then you've got a mid-sized conference room here, recessed in the ceiling 2x2, 2x4, 2x2. You've got a wall washer and a decorative, wall washer and a decorative. It would look something like this, right? If we look in 3 dimensions, right? Looking from the window wall in, looking from the doorway into the open office with the conference room here. So give you some sense in 3 dimensions. So the idea is, think about how you would do the lighting controls for this particular space, right? You've got a variety of information here in the lighting control schedule, the lighting schedule, fixture schedule, just like you would in others. You've got some information here about the specific offices, the target light levels, so what am I designing to? But then also, what are the initial light levels here, right? Why would I use that? Well, this is what I get when I turn everything on. So if I'm going to do task tuning, right, I can figure out how much I need to dim this initial 45-foot candles to bring me down to 30-foot candles to give my task tuning, right? And initially save a significant amount of energy. Now, how you go ahead and determine how you want to show lighting control zones, spaghetti wire, the zone annotation, the individual room annotation, that's entirely up to you. Do it however you'd like. But you wind up having this matrix that you can fill out. You can fill it out however you'd like to, right? Putting in the room numbers, the control zones, the space type, the lighting type, office, indirect or direct or accent lighting. What is the target light level that you're looking for, right? Lighting control station. I'll talk about that more tomorrow, what LCS means. It's better if I wait for that. But this will give you some idea, some way to sort of start to think about this space. Think about how you would group light fixtures together. Think about daylight zones. Think about occupancy or vacancy sensing. Think about how you would like this space to be controlled. Right? One of the important things here, there's no right answer. Potentially some wrong answers, but not many. So go ahead and we're not going to be turning this in. We're not going to be showing off our work or any of these things. But I would like you to go ahead and spend a little bit of time with thinking about the control zoning, about the strategies, about the hardware, about the sort of parts and pieces. Think a little bit about how you would initially go about this particular project. And then when we start out tomorrow, we'll actually go through a couple of different iterations of how this this might actually be done. Right? I'll show you how I would approach it in 2 different ways. So with that, I hope that's all clear to everybody. If there are any questions, go ahead and type them in now. It's been a great day. Katie, I'm just going to zing past this next couple of things. If anybody does have questions and they want to stay after, I am perfectly happy to do it. Although one here is, where can we download the homework? Download the homework from if you see a tab in your controller that says handouts. If you expand the handouts, you should be able to download from there. There are 4 files, right? There is the PowerPoint from today. There is the class homework file. It's a PDF. There's a study that's interesting that you can look at, and then there is the Excel file matrix. So that stuff should just download for you.
And yeah, depending on your browser, like when I click it, I use Chrome, and so all it does is pops up in the very bottom of my browser window that I've got an Excel document. So look for that in a browser maybe if you're trying to download it.
Okay. Then just a couple things. Of course, we'll be here tomorrow, but we'll talk more about these upcoming classes at the end of the day tomorrow. But we've got a bunch of network lighting control classes that are specific for various typologies coming up. And then, of course, if you want to get in touch with me, this is how you can do that. And we are part of Seattle City Light. Thank the City Light folks for bringing our services to the area for the last 32 years. Hard to believe it's been that long. I will answer questions in just a moment, but for those of you who are not going to hang out for questions, you'll have an online survey when you exit the webinar. Please go ahead and take that. We take the feedback really seriously. It's very useful for us with respect to tailoring these classes and what classes we're going to teach in the upcoming series. So let's see. Do we use the same link for tomorrow's meeting? Katie, that's a question for you. Do you use the same link, or is a new link come out?
There's a new link to. There are two separate registration links, so you should have two separate emails and calendar appointments. I think if you haven't gotten you should not have gotten the email for tomorrow yet. Oh no, it came out at 9:59 in my email box. So look for an email for tomorrow in your email box. That happened sometime during this morning.
Okay, great, thank you very much. Kelly, have you been able to download the homework? And is anybody else having trouble downloading the homework? Excellent. So that's good news. Are there any other questions? We have, I know that I'm a minute over here, sorry, but there's a ton of information to throw at you guys really quickly in order to kind of tie this class. Normally, like I said, normally this is a full day class. So anybody have anything? Also, we'll have a little bit more time tomorrow for stopping for questions. So if anything comes to you this evening, you need to write it down and send it along to us, and I'll be glad to answer and discuss any of that stuff. All right, well, not seeing any other questions, then I'm going to say thank you all for a good morning. And I will see you all, same bat time, same bat channel, tomorrow at 10. Have yourselves a fantastic balance of your afternoon. Thanks, Katie.
Thanks, Shaun. Thanks, everyone.